Good day, sir. My name is Kamni and my metric number is B0822101131. I'm a member of Group 4 and we will present about DC machine, shunt DC motor and also compound DC motor. As for introduction, a DC machine, often referred to as a direct current machine, is an electrical apparatus that uses direct current to transform mechanical energy into electrical energy or electrical energy into mechanical energy. The stator, which is stationary, and the rotor, which rotates, make up the essential building blocks of a DC machine. A frame, field windings, and magnetic core make up the stator. When a direct current is passed via the field windings, a magnetic field is created, generating the necessary magnetic flux for the machine to function. As for shunt DC motor, a shunt field winding is used in parallel with the armature winding in a direct current motor known as a shunt DC motor. The electrical connection of the field winding is referred to as a shunt. A shunt DC is built similarly to other DC motors with an armature winding and a commutator on the rotor and a stator respectively. The field windings, which are normally constructed of numerous turns of relatively thin wire and contained within the stator. As for compound DC motor, a series wound and a shunt wound DC motors characteristics are combined in a compound DC motor, also referred to as a compound wound DC motor. Its design comprises both shunt field windings and series field windings. Similar to the conventional DC motors, the compound motor has a stator and a rotor. It differs though in how the field windings are set up.
Hi, my name is Navinesh. Today I am going to talk about the differences between shunt DC motor and compound DC motor. For the shunt DC motor, the field winding is connected in parallel with armature winding. For the compound DC motor, the field winding consists of two parts, a shunt winding and a series winding. For the shunt DC motor, the field flux in a shunt DC motor is relatively independent of the armature current. For the compound DC motor, it's influenced by both the shunt winding and the series winding. For the shunt DC motor, have a relatively good speed regulation due to the constant reflex. They tend to maintain a relative constant speed under the bearing loads. And compound DC motor can provide better speed regulation compared to shunt motors because the series flux can help contract the armature reaction and voltage drop under heavy loads. And for the shunt DC motor, have moderately starting torque suitable for most applications that did not require high starting torque. But for compound DC motor, have a higher starting torque compared to shunt motors. The combination of series and shunt wheel endings enables them to provide higher torque at startup. And for the shunt DC motor, they are widely used in industrial process, conveyance, machine tools, fans, pumps, and various automation systems. For the compound DC motors, they are in applications that require higher starting torque such as electric oils, elevators, cranes, and rolling mills and heavy machineries.
So now I'm gonna talk on the advantages of shunt DC motors. The shunt DC motors have a wide speed range that making them versatile for different operating conditions, and it also have excellent speed regulation characteristics, and it also known for their high efficiency. And the DC motors have a straightforward control mechanism, and the DC motors got provided good starting torque, enabling them to start and accelerate the load of efficiency. The disadvantages of shunt DC motors are it is unreliable at low speed operation, and it also has a DC motors is large compared to alternative current motors, and it also have the installation of a DC machines that is expensive compared with other types of machines. And the motor is a constant speed motor where it will be a disadvantages where it is necessary to operate under variable speed. and then it also has the same current input where its starting torque is not as high as the DC series motor. The advantages of compound DC motors are it can provide a high starting torque which makes them suitable for application requirement, has a significant amount of initial force, and it also has designed to have good speed regulation characteristics, and it also has a wide speed range which means they can operate at a various speeds depending on the requirement of the application, and it also have a ability to deliver high power output compared to other types of DC motors. And the disadvantages of compound DC motors are it is it's a complex construction compared to other types of DC motors, and it also have a controlling compound where the DC motors can be more challenging to other motor types from comparing, and it also have a additional component that and complexity of component DC motors that can make more expensive than other types of DC motors, and it also have a lower efficiency compared to other motors such as permanent magnet DC motors or brushless DC motors. The last is the complex construction has a compound DC motors that can lead to increase the maintenance of the requirement. Thank you.
Now we are going to learn about the fundamentals of these motors. As you can see in the photo, a shunt DC motor's field winding is parallel to the armature winding. The motor shunt field winding receives some of the current. This setup lets the motor keep a steady speed under different loads. The armature current directly affects torque and inversely affects speed. Whereas a compound DC motor is a direct current motor that combines shunt and series properties. It has a shunt field winding parallel to the armature winding and a series field winding in series. The series field winding adds torque, especially at high loads, making the motor appropriate for high starting torque applications. The field windings of a compound motor determine its speed and torque. Moving to the principal workings of these motors. Shunt DC motors operate by interacting magnetic fields from the parallel connected shunt field winding and the armature winding. The motor rotates when electricity flows through the armature winding, creating a magnetic field and torque. The motor's speed is maintained by the shunt field winding's steady magnetic field. As for compound DC motor, the parallel connected shunt field winding and series field winding operate a compound DC motor. The series field winding adds torque especially at high loads, whereas shunt field winding maintains a magnetic field. The field winding gives the motor exceptional starting torque and load adaptability. So how do we use these motors in real life? Shunt DC motors have been used in electric vehicles because they provide good torque characteristics and can be controlled easily. This is the reason why EVs have good acceleration. Whereas compound DC motors are commonly used in elevators, lifts, and hoists due to their ability to provide high starting torque, precise speed control, and reliable operation. So that is all from us. Thank you.
And now I'm going to conclude the conclusion about DC motor, shunt DC motor and the compound DC motor. In conclusion, DC machines, also known as a direct current machines, are electrical devices that convert electrical energy into a mechanical energy. So these machines have been widely used in various industry and application for many years. Overall, DC machines have played a significant role in the development of electrical engineering and have been crucial in powering numerous devices and systems. While their prominence may have diminished in some areas, they remain relevant in certain applications and continue to be a fundamental part of electrical machinery. Thank you.